Hello everyone, I'm Venkat Narayan TL, a first year student at Sri Venkateshwara College of Engineering, Bangalore. Course title Mathematics 2 for Engineering. Topic Application of Triple Integration. So let's get started. The procedure used to define a triple integration follows that used for double integrals. Consider a function f of three variables that is continuous for a bounded solid region Q. Then encompass Q with a network of boxes and form the inner partition consisting of all boxes lying entirely with Q as shown in the figure. The volume of ith boxes delta Vi equals delta Xi delta Yi delta Zi, that is the volume of ith box. The norm of the partition is the length of the longest diagonal of the n boxes in the partition. Choose a point Xi, Yi and Zi in each box and form the Riemann sum. Summation I equals 1 f of Xi, Yi, Zi into delta Vi. Take the limit as norm tends to 0 to the following definition, leads to the following definition. Definition of triple integral: if f is continuous over a bounded solid region Q, then the triple integral of f over Q is defined as triple integration of f of x, y, z with respect to V. That is equals to limit norm tends to 0 summation I equals 1 f of Xi, Yi, Zi into delta Vi, provided the limit exists. The volume of solid region Q is defined by volume of Q equals triple integration Q dV. So triple integration of f of x, y, z dV can be evaluated with an iterated integral using one of the 6 possible orders of the integration. First order is dx, dy, dz. Second order is dy, dx and dz. Third order dz, dx, dy. Fourth dx, dz, dy. Fifth dy, dz, dx. Sixth dz, dy, dx. So evaluation by iterated integrals. Let f be continuous on a solid region Q defined by a is less than or equals to x, which is less than or equals to b. So h1 of x is less than or equals to y, which is less than or equals to h2 x. So g1 x, y is less than or equals to z, which is less than or equals to g2 xy, where h1, h2, g1 and g2 are continuous functions. Then integration Q. Triple integration Q f of x, y, z dv equals integration limit a, b, integration limit h1, h2, integration g1, g2, f of x, y, z, dz, dy. Let's take an example. Evaluate the triple integral of this problem. So here x and y as constant. So keeping x and y as constant and integrate with respect to z. So let's first take this condition and integrate it. Once after integrating this, we'll get an answer for this. Once after getting the answer for the second integration, let's hold x as constant and integrate with respect to dy. Once after integrating with respect to dy, we'll get an answer that is 19 by 6 integration integration limit 0 to x cube e to the power x dx. We'll get this. Finally, then we integrate this answer with respect to dx, which we get 19 of e squared by 3 plus 1, that is equals to 65.79. To find the limits for a particular order of integration, it is generally advisable first to determine the innermost limits, which may be functions of the outer two variables. Then, by projecting the solid q onto the coordinate plane of the outer two variables, you can determine the limits of integration by the method used for double integration. For instance, to evaluate triple integration q f x comma y comma z dz dy and dx, first determine the limits for z. So consider the limits for z, then consider the limit for y, and then consider the limit for x. Let's consider an example. Find the center of mass of the unit cube shown in the figure. Given that the density of the point x, y, z is proportional to the square of the distance from the origin. So its variable density is given here. This is the question. Because the density at x, y, z is proportional to the square of distance between the origin and x, y, z, you have P of xyz equals k x squared plus y squared plus z squared. You can use the density function to find the mass of cube. Because of symmetry of region, any order of integration will produce an integral of comparable difficulty. So m equals integral of 0 to 1, again integral of 0 to 1, and third integration 0 to 1. So k of x squared plus y squared plus z squared dz dy dx. First we are going to integrate with respect to z. Once after integrating with respect to z, we will get an answer as this. We will get the answer as this. After getting this answer, we are going to integrate with respect to y, taking these two limits. Then we'll get this. Once after getting this, we are going to integrate with respect to x. So after integration with respect to x, we'll get the answer, final answer as k. Hope you all have got an idea about triple integration and its applications. So I would like to conclude the video by saying thank you, goodbye, have a nice day.